series. So we have studied different sequences, arithmetic or geometric sequences. A sequence is essentially a list of values connected by some kind of pattern or a function. When it's arithmetic, the pattern is that you can go from one term to the next term by adding or subtracting a certain value. In a geometric sequence, we saw that there is a common ratio within the sequence from term to term. Now we're talking about a series, and what a series basically is it's the sum of the terms in a sequence. So we're going to start this off with an investigation. We'll take a few notes a little bit later, but the investigation says consider the sequence that is defined by the first 10 even natural numbers. So we're looking at 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our sequence of the first 10 natural even numbers. And we're going to complete the table to determine the sum of the terms in this sequence. So you have a column that's the term number, or number of terms. Then you have a column that says indicated term, and poof, there's the rest of the chart. Number of terms, 1, 2, 3, 4, and we could keep going. You have one more there, I think 5. Indicated sum. So basically what that means is if we take, in this row, one of the terms, the first term in the sequence, we get 2, which simply adds to 2, okay? If we take the first 2 terms, then we get 2 plus 4, which is 6. If we take the first 3 terms, we get 2 plus 4 plus 6, which is 12. If we take the first 4 terms, we get 2 plus 4 plus 6 plus 8, which is 20. And if we take the first 5 terms, we get 2 plus 4 plus 6 plus 8 plus 10, which is 30. Okay? Now, to find the mean, or the average, we're simply taking the sum and dividing it by the number of terms. Okay, so in this case, you have a term value of 2. There's only one term, so the average is 2. If we work down the list here, we have 6 is the sum of the first 2 terms. That gives an average of 3 for each term. 12 is the sum of the first 3 terms. It gives an average of 4 per term. You can see how the term average is climbing. The first 4 terms adds to 20. The average of that is 5. And the first 5 terms adds to 30. The average of that then is 6. And you can see we're actually creating a pattern in this column, the mean of all terms. But here's where it gets interesting. Let's take the mean of just the first and the last term of the sequences that we're talking about. So here, if we take the mean of the first and the last term, that one's quite simple. It's still just 2. Here, there is only a first and a last, and the average was 3, so the average stays 3. But let's see what happens when we take the average of term 1, 2, and 3. Except now we're just taking the average of term 1 and term 3. So we've got 2 plus 6, which is 8, and we're dividing it simply by 2 terms. So the average is still 4. Try it again for our first 4 terms in the sequence. Now we're looking at 2, and we're looking at 8 to be the 4th term. Well, that has a sum of 10 divided by 2, has a mean of 5. Let's look at our set of 5, the first 5 terms. We've got 2 plus 10. If we take the first and the last, that's 12 divided by 2. We're still going to end up with a mean of 6. All right. How is the sum of the terms related to the number of terms in the sum? What that question is asking is, can we find a relationship between this column, the values in this column, number of terms, and the values in this column? how does 1 relate to 2? And is it similar, can we create some kind of formula that will also get from 2 to 6, and from 3 to 12, and from 4 to 20? Well, I'm seeing a connection here that if I actually take n and I multiply it by n plus 1, I get the sum. If I take n and I multiply it by n plus 1, 2 times 3, I get 6. 3 times 4 is 12. 4 times 5 is 20. 5 times 6 is 30. And then the next question asks us, well, what's the connection between the number of terms and the mean of the terms? N plus 1. N plus 1. N plus 1. So you start to see the connection there. In question number 1, just under your chart, how is the sum of terms related to the number of terms? Well, I would say that the sum is equal to n times n plus 1. How is the sum of terms related to the mean of terms? Well, I suppose that would be the sum if the mean of terms is, let's just say m, then it's times by m minus 1 to get the sum, right? If this was m times m minus 1, you get the sum. If this is m times m minus 1, you get the sum. Let's keep working down and see if we can discover some more things. How does the mean of the first and last terms relate to the mean of all the terms? So how does this column relate to this column? And they are equal. So you can see why this might be helpful in a very long sequence where you'd like to find the sum of the first 100 terms. You don't have to add them up. You take the first and the last, and you find the mean, and then you could multiply by the term number in order to get the sum of all of the terms. Step 4, we'll get into that kind of stuff soon. Step 4, develop a formula for determining the sum of a series when the first and last terms are known. That's kind of what I was just talking about. If, let's say, we needed to take the first 100 terms and we wanted to take the sum of them, well, then we could take the mean of the first and the last, that's a and t sub n, and then we could find the average of that, which would simply be dividing by 2 because it's just the first and the last. And then we can multiply by the number of terms that we're interested in finding, okay? So basically what we have here is we had the first term plus the last term over 2, because there's 2 terms, we're finding the mean of them. We're going to take that and we're going to multiply by n, right? We'll get the mean of the first and last term, which is the same as the mean of all the terms. And by definition of mean, in order to get the mean, you're basically taking the total sum and dividing it by the number of terms. So if we take the mean and multiply it by the number of terms, we should get the sum. Determining equals the sum. Okay. 5, test your formula on this series. So I'm going to leave those last steps for you. Number 5, test your formula that you used here. So you're going to find the sum of the terms just by adding up all of the terms in the sequence. And then you're going to use this strategy and see if you end up at the same answer. So let's go and apply what we know to this new sequence. We've got 1 plus 3 plus 5 plus 7 plus 9 plus 11. How many terms are there? There are 6 terms. So n is 6. The first term is 1. The last term is 11. I'm going to divide that by 2. And what I should get is the sum. So here we have 6. Here we have 12 over 2, that's 6. And we have 36. Well, let's see what happens when we actually add 1 plus 3 plus 5 plus 7 plus 9 plus 11. Here we have 20. Here's 32 plus 4 36. All right. In step 6, consider the following. We're going to make another comparison to that formula that we just developed. It says, and you're going to have to copy this down, but we're going to take the sum of the first 6 even numbers. So we're going to take 2 plus 4 plus 6 plus 8 plus 10 plus 12. Then we are going to write them again in reverse order. 12 plus 10 plus 8 plus 6 plus 4 plus 2. And we're going to add all of these up and then divide by 2, okay? So we're going to end up with 14 plus 14 plus 14 plus 14 plus 14 plus 14. Something significant about those all being the same. And then we're going to divide by 2. And what we end up with is 14 times 6 divided by 2, which is 42. All right. Now what if we took that same information and we plugged it in our formula? If we took the value of n, which is 6 for the first 6 terms, and if we took the average of the first and last term and divided it by 2, well, we would get 6 times 2 plus 12, which is 14, over 2, which is 6 times 7, which is 42. Now this thing that we just did, writing the series, the sequence one way, the series really, because now we're adding, we're taking the sum of the first 6 terms, that would make it the series. And then we're writing it in reverse and taking the sum of it all. This is going to help us generate a formula for finding the sum of the indicated terms of a series. So at the bottom of that page, you have space for a few notes. The first note that we're going to take is on the term series. This is the indicated sum of the terms of a sequence. The indicated sum of the terms of a sequence. Now this word indicated is in there because you can take the sum of the first 2 terms or the sum of the first 120 terms. This is the indicated sum, okay? Then we have a note on arithmetic series. Arithmetic series. So today we tackle arithmetic series, the indicated sum of the terms of an arithmetic sequence, and tomorrow we'll do geometric series, which is the indicated sum of the terms of a geometric sequence. Okay, and there's a different strategy for developing a formula for each of these. So this is it's the same as above, the indicated sum of the terms of a arithmetic sequence. We'll write it. The indicated sum of the terms of an arithmetic sequence. All right. For any arithmetic sequence, comma, the terms can be written. For any arithmetic sequence, the terms can be written, and this we're familiar with, written as a, comma, a plus d, comma, a plus 2d, comma, a plus 3d, comma, etc., until we get to the last term, which is, here's the second last term. If we're looking backwards from the last term, which we don't know what it is, but it's the value of the last term, and then the term before that would be the value of the last term, take away one of the differences that we've been adding all along. Moving this way, you simply moving this way, you take one away. Okay? Well, if this is true about an arithmetic sequence, then the corresponding arithmetic series, is, and I'm leaving a little bit of space to the left, I'm going to add something there for you in a second, a plus d plus a plus 2d plus dot dot dot, a whole bunch of terms in between there, and then our last two terms, t sub n minus d plus t sub n. Okay, an arithmetic series is simply the sum of the indicated terms, the indicated sum of terms in the sequence. So here we have the series, and we don't know how many terms there are in this particular one. It's a general case. We're taking all of the terms indicated here. Okay. Now, what happens when we write this series in reverse? Okay. So it's still going to be the series, the same series, and we're going to write the series in reverse. Okay. That means we're going to go t sub n plus t sub n minus d plus t sub n minus 2d, and it would keep going, t sub n minus 3d minus 4d minus 5d, until we get all the way back to the start, in which case the first two terms in reverse are a plus d plus a. Now what we're going to do, just like we did in the investigation, we're going to add the terms of these series up. Okay, so we're going to add them up, which means on the left of our equal sign, we have 2 times this series, the sum of the series, okay. And here we have a plus t sub n. Here we have a plus d. Well, I'm not going to write it, but look at what we have. We have a plus d plus tn minus d. So we've got plus d minus d, that's a wash, and we have a plus tn. Same thing happens here. We have plus 2d minus 2d. So we're just left with a plus t sub n. And that continues all the way along until we get to the very end, and you can see what's happening there still. Negative d, positive d. You're still left with a plus tn. And the sum of our last terms is also a plus tn. So we have this binomial, a plus tn, being added to itself over and over and over and over again. And repeated addition can really just be represented by multiplication. On the left side here, we still have 2 times the series. And on the right here, well, how many factors would there be for this binomial? If we were multiplying it, we would have, if t sub n is the last term, then how many terms do we have? Well, we have n terms. Or you could look at it this way. The series includes the first n terms of the sequence. So we have a plus t sub n times. Okay? Now, in order to develop our final formula for the series, we're going to divide both sides by 2. Now, divide both sides by 2. And what happens is we have the series, the indicated series. If we divide this whole right side by 2, that's the same as just taking one of the factors and dividing it by 2. So we have n over 2 times a plus t sub n. What we have here is a formula. I'm deliberately leaving some space here just so you know. A formula for the sum represented by s sub n of the first n terms of an arithmetic series. Okay, so this is one formula that allows us to find the sum of the first n terms of an arithmetic series when we know the number of terms, the first term, and the last term. Okay, a couple of lessons ago we were talking about arithmetic sequences, and we actually developed a formula for t sub n, which means that we can develop a second formula that will allow us to get the sum of the first n terms of an arithmetic series even when we don't know the last term. Okay, so I'm going to sub in t sub n equals, if you remember what that formula was, a plus n minus 1 times d. Okay, and you'll see what happens when we plug that in. I'm going to do it in pink because I need to simplify it once we're done. But we have n over 2, and we're going to have a double set of brackets, so I'm going to use a square bracket. This a just comes down, and what we're going to do is we're going to substitute in, for t of n, t sub n, a plus n minus 1 times d, and close off that double bracket. Now you can see you have like terms that you can add together. So the second formula for determining the sum of the first n terms of an arithmetic series starts the same way with n over 2, but now what we have is 2a, square bracket, 2a plus n minus 1 times d. And these are our 2 formula that will allow us to do what we need to do here in working with arithmetic series. In example 1, we're asked to determine the sum. So we have our two formula. We'll just run through them quickly. I can determine the sum if I know n, if I know the first term, and I know the last term. Okay? Or if I don't know the last term, I can still do it using n and the first term and the common difference. So in this formula, I need the common difference. I can do it without knowing the last term. In this formula, I don't need the common difference, but I do need the last term. In example A, we're going to do it both ways, okay? We're going to first use formula 1, and you will have these memorized shortly, but for now, just jot them on the top of your page so you don't have to copy them down each time. And I'm going to copy it down here for the sake of the example. But we have the sum of the first n terms is n over 2 times a plus the last term. Over here, when we redo it, we're going to have the sum of the first n terms is n over 2 times 2a plus n minus 1 times d. And now we just fill in what we know. So in this case, they've given us more than enough information. We have enough information to use either formula, in which case you'd probably just use the first one because it's a bit shorter. So we're going to find the sum of the first 10 terms. So we're going to take 10 over 2. We know that the first term is 2, and we know that the last term is 38. We reduce this, we have 5 times 40. The sum of the first 10 terms then is 200. Okay? Let's go across, and just for the sake of practice, we're going to use our second formula. We have the sum of the first n terms, So to get this first 10 terms, again, we have 10 over 2. Then in the bracket, we have 2 times our first term, which is 2, plus n minus 1. We know n is 10 because we're looking for the sum of the first 10 terms. And we know the common difference is 4. Close it up. So outside the bracket here, we have 10 over 2 is 5. Inside the bracket, we have 4 plus 9 times 4, which is 5 times, and I'll do every step, 4 plus 36 equals 5 times 40, which equals 200. Okay, so the sum of the first 10 terms of this arithmetic series is 200. You can see that method 1, if you have the information that you need, is obviously faster and easier. But method 2 will still work if you don't have the first term, but you do have the common difference. Okay? Let's look at example 1b. Example 1b, we are told that the first term is -4, and that the common difference is -3. And we want to get the sum of the first 10 terms. Well, I don't have the last term given to me, so I have to use formula number 2. So I'm going to copy that down. The sum of the first n terms is n over 2 square bracket 2a plus bracket n minus 1 close bracket times d square bracket. Therefore, the sum of the first 10 terms, we know n, okay? Might look like we don't know n because they didn't give it in the question, but we are looking for the sum of the first 10 terms. So n is 10. 10 over 2, square bracket, 2 times -4, plus 10 minus 1 times d, close it off, gives us 5, and then inside the brackets, we have 2 times -4, which is -8, plus +9 times -3, close it off. We're going to do the rest of the bracket in one step. We've got 9 times -3, which is -27, minus 8, which is -35, and 5 times -35, it'd be 5 times -30, which is 150, and then another -5 times 5, which is another -25. So you got -150 and -25, which is -175, if you don't have your calculator. If you have a calculator, you just punch it in. Okay, so the first 10 terms of this arithmetic series is -175. We are forced to use our second formula because we did not know the last term. In example 2, we're asked again to determine the sum. This time we're not given a lot of explicit information. We're just given the first 3 terms. Okay, so this series continues on and on and on and on, and we're considering the first 15 terms. So, I mean, we could think about this kind of from step to step and go, okay, well, the next one is 0, and then -4, and then minus -8, and then minus -12. And we could think about it that way and kind of get a picture of what's going to happen here. But we also know that if we have a formula, let's use the information that we know and see if we can solve this. So we do know, what do we know? Well, we know that the first term is -12. We do not know the last term, so it tells me that we're going to be using our second formula. And what do we need to know in order to use the second formula? We need to know the common difference. Do we? Well, how did you get from one term to the next? It appears as though we know it's an arithmetic series, and we know that there's going to be a consistent change from one term to the next. It looks like it's +4. -12 plus 4 is -8. -8 plus 4 is -4. So we have enough information to plug it into our second formula. Let's go. We've got the sum of the first 15 terms is equal to n, which is 15, over 2, times 2 times a, which is -12, plus 15 minus 1 times d. Close it off. I'm going to leave this guy as a fraction. Helps me. I don't need any decimals in here. We'll just leave it till the end. 15 over 2. Inside the brackets, we've got negative 24 plus 14 times 4. All right. In your calculator, this reduces to this whole inside the brackets reduces to 32. And now I know why I didn't go into a decimal is because, well, 32 divided by 2 is real easy. I'm left with 15 times 16, which is 240. Okay, so the sum of the first 15 terms of this series, just given the first 3 terms, we get is 240. Same strategy for example 2b. Our terms in the series look a little bit funnier. We've got negative 11m, negative 2m, and positive 7m. What can we determine? Well, our first term is negative 11m. And because they give us 3 terms, we can find the common difference. Looks like we're adding 9 m's each time. Yep. So plug it in. The sum of the first, what are we going for this time? We're going for the first 20 terms, okay? Should have written that up here. The sum of the first 20 terms. So n, we could write, is 20. Sum of the first 20 terms, we have 20 over 2, n over 2, in brackets, 2 times a, which is negative 11 times m, plus n, it's 20, minus 1, times d, which is 9m. And from here, it's really just basic algebra skills. 20 over 2 is 10. Negative 22m plus 19 times 9m. 19 times 9m. So we're dealing with m's. We have 9 times 19 of them. Then we are going to subtract 22. And then we're going to take that value. Well, we'll just write that step. That's 149 m's. And multiply by 10, we have 1,490 times m. So the sum of the series, the first 20 terms in the series, is actually dependent on the value of m. Okay, and that's fine. Don't be tricked by that in your answer. You've got m's in your terms, and they would need to be known if you were going to add all this up. But you know that you have 1,490 of them. All right. In example 3, we are asked to find the sum of an arithmetic series given the first 3 terms and the last term. The difference here is we do not know the value of, we don't know what n is, okay? We don't need to know that. We have lots of other information. So what do we have? We've got a, which equals 3. That's your first term. We have a common difference, which is positive 5. And we have the value of the last term. Okay, so we could do this either way, but in order to actually find the sum using either formula, what do we need that isn't already here? We need the value of n. Okay, they both formulas require the value of n in order to find the sum of the indicated sum of the series. So what we actually need to do is use our formula that we used a couple lessons ago for the last term in a sequence, which is t sub n is equal to a plus n minus 1 times d. And all of this information is the same. So we can use this formula to determine what n is, and then we can sub n into either formula for our arithmetic series and determine the sum of the first however many terms it happens to be. We're going to find out how many terms it is between 3 and 58 inclusive. Okay, so here we go. The last term we know is 58. We know a is 3, We do not know n, but we know d is 5. So now we're going to use algebra to figure out, to solve for n. 58 is equal to 3 plus, oh sorry, I have d equals 5 there, okay? 5n minus 5. So here we've got -2. I'm going to add 2 to both sides then. So we're going to give us 60 equals 5n. Divide both sides by 5. N equals 12. Okay, now that I know that n is 12, I can take that value and I can sub it into either formula. I am going to use the first formula because it's easier. And I know now that I'm looking for the sum of the first 12 terms. All right, so we've got 12 over 2 times 3 plus 58, which is 6 times 61, which gives us a final answer of 366. Now you could use formula 2, but pick the one that's easiest to use if you have the information that you need. So the sum of this arithmetic series is 366. The first thing we had to do was use an older formula for the general term in a sequence in order to determine what n was, and then sub that into our new formula for the sum of the first n terms in an arithmetic series. In example 4, we're asked to compare wages. A student is offered a job with a math teacher that will last 20 hours. The first option pays $4.75 for the first hour, $5 for the second hour, $5.25 for the next hour, and so on. The second option pays $7 an hour for all hours worked. Okay, we're going to find out which option pays more. I erased our formulas because you have them memorized. Well, let's just think about what we know here. What do we know? Do we know the first term? Yes. First term in this series will be $4.75, or 4.75. Do we know the common difference? The difference between terms? Yeah. Each hour is going up by 25 cents, so 0.25. And do we know the number of terms? Yeah, he's working for 20 hours, or she. So there are going to be 20 terms in this series. We don't know the value of the last term, but that's okay. We have enough information to use formula number 2, which you have memorized. So go ahead and jot it down, and then check back. All right, let's find the sum of the first 20 terms using option 1 and formula 2. We've got 20 over 2 in brackets, 2 times 475, 4.75, plus 19 times 0.25. Close it off. That gives us 10. 2 times 4, we'll just do this, click, click, click in your calculator. You end up with 14.25, which after 20 hours, with this payment scheme, the student will earn $142.50. All right. Well, over here, option 2 is simply $7 an hour times 20 hours, which is $140. Which option should you pick? I'd probably still go with the 140, so I didn't have to do all this work. But if she's real desperate, we'll go with option 1. The math teacher's going to do all the work anyway. So the first option pays more. All right, your practice problems for lesson 6.6 Arithmetic Series are found on page 400 They are numbers 1 through 12.